and today we're talking about anemia. I'm Amanda Armagos.
And I'm Dr. Abbasi for Essence. Now, anemia. Where is the origin of the word anemia?
That's a good question. I don't know.
Well, practically, this is a combination of a preface a or a and anemia, meaning that not enough blood, not enough. So, like, there are lots of other things that
Because A is like not,
A
right?
is not, no, not enough or not enough blood. And obviously, I guess for thousands of years again, we have known that there's something inside of us is red, and if we lose enough of it, then we die. Or if that always a dangerous thing. As a matter of fact, we have developed to have this fear of everything that's blood colored red. Like for that reason, like if you go to a stoplight or a street light, it's red. Red means don't go.
And if you're like, for example, mushroom hunting or foraging or something, and you see a red plant, like especially a red
Mhm.
mushroom, odds are you know that that's not going to be a safe thing to eat.
Yeah, but mostly in our biology, everything red we are afraid of because red should be inside, not outside of our
Mhm.
body. And now, first of all, why is blood red?
The oxygen, the
Mm,
hemoglobin.
hemoglobin, but it's because of the iron of
Mm.
the red planet, Mars has iron oxide, and that's why it's called red planet because the surface is full of iron oxide. And hemoglobin is like this wonderful thing that's unbelievable. It is an iron atom. An iron atom inside is connected to four different big molecules, huge molecules. Each of those molecules can carry um, an oxygen atom, an elemental oxygen from air. And the beautiful part of it is that, you know, every gas is soluble in different liquids. Like oxygen is soluble in water to a certain degree. But once you get that hemoglobin, the molecule, this big molecule, absorb the oxygen and binds it to its big hemoglobin molecule, then all of a sudden there is more space in the serum. Serum is the fluid of the blood. So blood, if you just spin it, it's made of multiple areas. If you spin it hard, then you first see on the bottom, you see the um, hemoglobin or erythrocyte or cells. On the top, you see this very thin film of white material, which are white blood cells. And on top, you see the serum. And practically, serum itself is like any other fluid, carries certain amount of oxygen. But by adding a red blood cell or hemoglobin to that, it can carry hundreds of times more oxygen and circulate in our body, which we then use to practically survive, to burn glucose to energy and survive. So, and the reason hemoglobin is red is because of the iron atom inside of it. Now, there are some prehistoric uh, crabs that instead of iron, they have copper
Oh
in that
wow,
place. Yes.
that's crazy.
Did you know that?
No,
What color do you think their hemoglobin or blood is?
orange.
No, green.
Oh, okay, yeah, because it oxidizes.
Yeah,
Yeah,
yeah. See,
that's
like a
crazy.
Statue of Liberty. What
Hmm.
color is it? It's green.
Green.
It didn't used to be
Yeah, it
green.
used to be copper.
No, it used to be actually mostly whitish color.
White?
Yeah, whitish color. Yeah,
Wow.
but then over the many decades and centuries, what happened is that the outer layer oxidized and then became the green color it is now.
Okay,
So
cool.
and so, by the way, a gallon of the blood of those crabs is like $60,000. So if you can go and milk the blood of those crabs, you can
So
be
they're
a very
still,
rich.
but they're still alive now.
Oh yeah, there's still we
What are
still
they
have them.
called?
Oh, there are crabs. There are
Yeah,
certain
but there's so
special.
many kinds of crabs, like
Oh
blue
yeah,
shell crabs, soft shell crabs,
horseshoe
hurling.
crab. I would call them horseshoe crabs.
Oh, okay, I've seen a horseshoe crab.
You have seen that? They're very flat and almost like a dome with like a
Yeah,
small little
purplish.
dome. Yeah, yeah.
Yeah. Oh my
So
gosh.
yeah.
Wow. So my understanding of anemia or being anemic, I used to think of it as not having enough iron in your blood. And the reason I wanted to do this podcast is because two-parter. One parter is I'm a vegetarian. Everyone knows that. And people always say,
Everyone knows that.
everyone that watches knows that. And people always say, why like aren't you afraid of your iron levels? Do you think you're getting enough iron? So one time I did actually, or a couple times I've gone to the doctor and had my blood tested to make sure my iron
Mm-hmm.
levels were okay, and they were. But now I'm understanding that it's maybe not the iron, but the red blood cells. Having too
Mm-hmm.
little red blood cells would make you anemic. Is
Mm-hmm.
that accurate?
So now that's so many facets to what you just said. Number one, being vegetarian and being anemic. Well, most of the animal worlds are vegetarian. They have no problem with the being anemic and so
You
on.
don't have to help me defend vegetarians. That's what I always say. I'm like, you think an elephant?
Is
Like, come on, like, come on. You
or
think an elephant's
cows
concerned
or
about their?
sheep
Yeah, you
or
think they're concerned about their protein?
no. So obviously um this is what let put it then let's dissect that.
Hmm.
Being vegetarian, you have to be more conscious about what you eat than if you are not vegetarian. That's just the way it is. Because we are omnivores. Omnivores meaning we eat everything. If you look at our teeth, we are not carnivores. We are definitely not carnivores, but we are not completely vegetarian either. Our diet is a diverse diet. As a matter of fact, we call human like more than any chimp or anybody else, uh, opportunistic
Hmm.
omnivore. What does that mean? That our diet is mostly gathering fruits, roots, leaves,
And the animals that we can luckily catch.
or animals that somebody else caught, and we just get access to them. We don't even have the right teeth to open up a skin of any animal. We are miserable
Yeah.
compared to, I mean, let me tell you something how miserable humans are. A mouse is faster than Olympic sprinter. A mouse, repeat that, a mouse is faster than Olympic sprinter. Okay? So that is how miserable we are. Now, our teeth are like not only teeth, but as well our jaw closing. We call that bite pressure is like less than a cat. I mean, a dog. Your dog has probably little dog has probably three times more jaw pressure
You
than
guys, my dog's 10 pounds.
yeah. And but psi per per a pound per square inch of any animal, we have probably the lowest jaw pressure. As a matter of fact, they did a study. One of the reasons humans are human is because our jaw pressure is so miserable. Okay, this is beautiful. I'm sorry, it's an
No,
excursion,
it's
but I
fine.
have to say that.
Say it.
Now, there are these diseases called muscle dystrophies. The most famous one is so-called Duchenne muscle dystrophy. Practically, in that muscle dystrophy, the leg muscle they go and other muscle, and then later on lung muscle, chest muscle they go on, and people cannot even breathe; they die. Okay, so and then there's a huge variation of these kind of muscle dystrophy. There's muscle dystrophy that just muscle in your eye cannot move, and so on and so forth. It's amazing how it works. Eventually, we found out that human have a genetic variation that made our chewing muscle. No, everybody, put your hand on your temple and chew. Do you feel it?
Yeah.
We have a bone here called a zygomatic arch. Underneath, there's a muscle, the so-called masseter muscle going in, and the masseter muscle connect to our lower jaw and help us to chew. And if you compare that us to any other animal, we are miserable. Like a gorilla has like 2,500 times more the bite pressure in their jaw than we do. They can crush anything. Now, are we so weak? It's not actually a genetic disease. practically humanity, sometime in their life, they got a human genetic disease that our bite pressure was so reduced, and two things then happened. Now, imagine if you had 3000 psi, human has like 50, 60 psi jaw pressure. Imagine you were an animal that you had like 1000 psi, one end of the muscle attached to your skull here. As a matter of fact, when I do brain surgery, I have to detach it in a certain way to reattach it, and so on, otherwise people couldn't call, chew, and so on. But imagine if we had that kind of pressure here, and babies, when we are born, there is an open ridge
Mhm.
in the middle of their skull. We call that, the I forgot the name. It's an area that the bones are not connected. Imagine if we could produce that much pressure, it would split open our skull. For that reason, chimps and gorillas, by the time they are born, not only this is closed, this ridge is closed, but as well this ridge by those animals, it is actually a ridge because it's a huge amount of bone here with lots of muscle attached to that that cannot split. If that split, the skull opens wide open, they die.
Mhm.
What does that mean? Meaning that by the time they are out of the womb of their mother, the brain is completely done. The size of the brain is set by the time they are born, whereas human brain size is not even having started. All those that the openings are open, so brain can get bigger and bigger and expand. As a matter of fact, the brain is very undeveloped. Like we know that a gazelle, 20 minutes, 5 minutes after they are born, they can start sprinting and
Mhm.
walking. Human takes about a year before to do that because our brain, our nervous system is not developed. But what does that mean? We can have better brains that is unfinished when we are born. It can still grow. And the only reason we can have that is because our chew muscle are not strong enough to split open. So the genetic disease that we inherited made us be able to have bigger brain. But as well, now imagine you have a bigger brain, but you chewing like weakest animal on the planet. You have to compensate for that for your smartness, using
Exactly.
tools and so on. So let's come back to that. We were opportunistic animals. We ate mostly what we could gather, and if somebody some and but we were weak, we couldn't open. But if some other animal like killed a bison or something else, then we would go get the rest. But then we developed ways of cooking that meat that make it more palatable, kill
And
the
we also developed
bacteria.
tools to like cut the animals open,
Yeah, eventually we did.
knives.
Eventually we did, and all of that feeds to that we are our diet naturally should be 90% not meat and less than 10 5 even 5% meat, and that is a healthy diet actually. Okay.
Yeah, like the Mediterranean diet. That sounds like that.
Yeah, yeah. Now, but that amount of meat that we get is enough to give us many
Protein.
special. No, see, the protein itself is certainly important, but you can get protein from many other
There's
sources.
different types of protein.
Yeah. And obviously if you eat an animal, you get more so-called essential amino
Yeah.
acids. Okay, there are 19, and there are five of them that our body cannot produce. As a matter of fact, four. The fifth one, the one now we know that probably our body can produce. Um, but when you eat an animal, you get it already. But if you are vegetarian, you have to have a diverse diet. That is why we human eat so many different things. Naturally, try to eat for a week the same thing. You just cannot stand it anymore. And this is in our nature that we cannot stand it because our survival depends on having a various diet. Okay.
There's some people that do color diets and then they choose one color a day and only eat that color for an entire day.
Well, I think our body more or less regulates and so on,
Right.
but I'm talking about nobody likes monotonous diet.
No.
So and that there's a biologic reason for that. So you get what you need. Now we talked about that huge part of building hemoglobin or red blood cells is iron. Iron is the one of the most abundant things on the planet, but it is not available to us. It is only available to us if it is a kind of the ionic iron in a certain, because iron comes in a two electron shell or three electron shell. It comes in different variation. Only the special kind of iron is our body is able to absorb that, because that's the one that goes to hemoglobin. We don't need any other iron. As a matter of fact, if you eat any other kind of iron in abundance, babies, if they eat that iron pills, they may die even of it. Okay,
Hmm.
so
A lot of people, there's, what do you think of this? There's this thing called like a iron fish. Have you heard of that?
no.
So when you're cooking something that's acidic, tomatoes, lemon, something like that, chicken with lemon, then you can put this fish that's made out of iron in your pan while you're cooking. And if you have an issue with iron deficiency, supposedly that it helps you to get more iron.
Well, I don't know what to think about that, because considering, you know, that is elemental iron in certain way that our body absorb. I don't know how much of that will get. It's not like a iron metal that we can absorb. So it's a literally a kind of iron or salt that we are able to absorb. So I don't know much about
It
that.
sounded fishy to me.
Hmm?
When I heard about that, I thought it sounded weird.
Yeah, yeah. So okay, but we're talking about anemia.
Hmm.
Iron is only one part of it.
Yeah,
So, what is the average, hemoglobin in like 100 cc of blood?
you have to ask Alyssa.
Mm, It is about somewhere between 12 and 14 grams, meaning that 12 to 14 gram of blood is actually hemoglobin. The rest is plasma. But very interesting, I see it always in my ORs that um, 10 cc of blood, if you splat it on the field or floor, you think it's like a 10 times more, because we are so overconscious about that. And you need a very little blood to add to any fluid to make it to think it's all blood. It is sort of our eyes, our biology is so so overconscious about the blood and so on and so forth. And what that means that, now we have a lot knowledge to know what is a healthy amount of hemoglobin in the blood, and you need iron to build hemoglobin, but you need as well these packages of hemoglobin. We call them red blood cells. As a matter of fact, red blood cells, they don't have any nucleus. It's a one-way ticket. Now, our body builds them. They are cells that they live certain amount of days and so on, and then they get uh, recycled in our spleen mostly, and then and in our spleen and in our liver. As a matter of fact, the product of the waste product of hemoglobin become like a gallbladder content, and then that's what give our stool the color of the stool.
Oh, I always wondered that
Yeah,
actually.
yeah, that is a color of the stool is the byproduct of the breakdown of the hemoglobin that gives. First it makes it so our body is recycling it. First is the red blood cell and hemoglobin. Once it's done, it goes to our gallbladder and becomes material that help us to digest fat better, and
Mhm.
then it gets even more, and then comes out in our mostly in our stool. Now, but regulating, how much hemoglobin is in red cells, that is another path in our body that is regulated by many, many hormones and so on that practically tell us how much red blood cell we should build. And do you know where mostly we build red blood cells?
Where?
In our bone marrow, inside
Oh,
of our
okay.
bones. Again, another place where our body recycles the spaces and so on. Liver is as well is a place that red blood cells are produced, especially in children and so on. But mostly in adult is the in our bone marrow. The all our blood cells are reproduced and produced, but mostly the red blood cells. Now, anemia is practically if you don't have enough red blood cell or hemoglobin in your body, and there is a hormone called erythropoietin, and that practically that your kidney and produces that if there is not enough hemoglobin, and it literally makes those stem cells in your bone marrow to produce more of that. And there is actually there are good stories about in the old age how you would know if somebody has anemia or not. You're, I think I showed you
Yeah,
one.
you've done it to me one time because that's another question I had is my face was looking to you white. Why when you don't have enough red blood cells, why does it actually maybe make your skin look
So
whiter?
why do you think we have, there are two reasons we have our skin color. One of them is amount of melanin in our skin, and obviously, if you're in the darker spaces, darker, if you're in if you're in the more high IUV places, you have more melanin.
To protect your skin from the sun.
Yes, yes. Um, but then the other reason is that because you have blood going under the skin in your tissue.
Why why are your veins more prevalent then?
Well, the veins are have a lot more hemoglobin. What that means is that you have more color red there.
But they're blue.
Well, they look blue because they're what we call desoxygenated, meaning the oxygen is taken away from them. So hemoglobin, you remember we had that the iron molecule. The iron molecule, it is really red when it's connected to oxygen. Okay, so when you take the oxygen away from that, is not as red. So meaning that blood that has more oxygen, our arteries are red. Blood that are in our veins that have less oxygen, they are less red.
Mm,
It is not, they're not really blue. But what happens if you mix color blue and color red?
you get purple.
Yeah, that is no yeah, that is mostly that because they don't have enough oxygen in them, and they have to go through more pink tissue. They appear more purplish,
Mm.
bluish, black, and so on. But they're not really blue. Now, one of the old my old teachers when I went to med school in Heidelberg, they showed me before the time that we had any access to these labs and so on, is that so if you have like keratin and I'm sorry, melanin and so on, you don't really see the capillaries. But there are few places in your body you can see the capillaries. And literally, if you take your hand and turn them like this way, then you see the lines here. That is where
What
there's no
lines?
melanin. That means that you see the capillary, meaning that if you see it very red, meaning your blood, my hemoglobin is probably 14. And if I'm looking at you, I don't see it in yours. Yours probably around 10 to 12. So here's better. Okay. But look at even here with me. So that is an old way he showed me. And another place that I think nail beds, you see, you push on them and you see how fast they fill back. At first it becomes whiter, but if it doesn't feel, it become purple. I'm sorry,
Pink again?
pink again right away. Then meaning that as well you have low hemoglobin. So
So when someone has low hemoglobin or someone's anemic, a lot of times maybe they're like lightheaded, right?
well, what does blood do for us? It gives
Oxygen.
oxygen and other material that our body needs, especially to our brain. And if there's not enough oxygen to our brain, we now all know what that happens. You pass out. You're less able to deal with any kind of stress, like high activity level increase and so on and so forth. Like same thing happens if people are like from lower altitude, they go like to
Mm-hmm.
Himalaya, higher altitude, where there's less oxygen, then they're lightheaded, and that can be even deadly because if brain doesn't get enough oxygen, it may swell, and that brain edema that can be very dangerous. And you know how nature deals with that with people like are up there in Himalayas, in Nepal, and so on. Their hemoglobin is like much higher than us. Like our hemoglobin is 10 to 14. their hemoglobin is probably 16, 17, 18. But there's a problem there. If they come to our altitude, then those lots of hemoglobin make it more clumping together.
And they can get blood clots.
They can get more blood clot. If you have more hemoglobin, it's just become harder to push all of that um, through your capillaries and so on. So nature has always tried different variation and optimize for the place you live. Now, one of the reason people when they want to go to high altitude, they go to these base camps, and there are many of them
Hmm.
to acclimate because after a few days, your body produces more hemoglobin, erythrocyte, and so on. So you can then adjust it to that level. Then you go to the next level, and so on. So that is what they do to create more hemoglobin before you go to higher levels. But again, coming back to that, the main reason for anemia, statistically, in the woman is like, believe it or not, is the menstrual bleeding. Monthly menstrual bleeding is not much, but sometimes it can be enough. And if you combine it with bad nutrition, less iron, and so on, that can add up to be that the most reason for anemia. And there are obviously, nutritional related anemia, and then in elderly, sometimes the reason is like in your GI tract, it's just random bleeding and so on. That can be a reason. And kidney problem can be a big, because the hormone erythropoietin is produced in our kidneys that makes our blood cells to literally our stem cells in our bone marrow to reproduce and create more blood.
So when people are anemic, is it usually treated with lifestyle or diet changes or medicine?
Well, depending on how, no, number one, it's very important to understand how low your hemoglobin is. Now, if your hemoglobin is chronically low, your body adjusts to that. You can tolerate, some people can tolerate blood hemoglobin. You remember normal value is 12 to 14. If it's chronically, some people tolerate 6, even 5. If you take somebody who has a 12 and let them bleed until they go to 4 or 5, they almost always die. But if you make it chronic thing, your body adjusts to that, and then you can tolerate that. Now, if the reason you're anemic is because you're losing blood acutely, then you have to transfuse blood. And there's a good story there too. But if the reason is that you're missing hormones, sometimes we can give those hormones. As a matter of fact, those hormones you can even squirt it in your nose
What type
sometimes.
of hormones?
Well, there are multiple hormones. As a matter of fact, one of the hormones that we sometimes give is also called oxytocin, even for this situation. But like erythropoietin, that is the hormone we talked about. You can give it, and that can produce more blood. Now, if the reason is that you don't have enough iron, now guess what? With our big brain that doesn't split open, we create pills that have iron exactly how our body needs. Now, there as well, but the problem there is that for iron to be absorbed, you have to have a good GI tract. There's some problem of the GI tract, like stomach problem and so on, that makes you're then unable to absorb the iron that you give that. Then you can give iron, obviously, shots, but I would stay away from that.
Unless you like absolutely need
Yeah,
it.
absolutely need that, but they are really not preferred. I don't believe in medicine there is anything that if you can give it PO, you should give it IV, because our body over millions of years has created these checks and balances to get what it needs. Certainly, if the situation is difficult and not, there are other problems, then certainly IV is preferred route.
Essence of Medicine, and we talked about anemia. I'm Amanda Armagast.
And I'm Dr. Abbasi for Essence.
Have a good weekend.
You